Hello guys, and welcome to this new video. This video is a C programming crash course in which we are going to be going through all of the topics and concepts that I think anybody interested in learning C for the first time should know or be aware of. Now this video is intended for complete beginners who have never written any code in C in their life, or even people who don't know anything about programming but want to start learning programming or C programming in particular. After watching this, you are going to leave from a complete beginner to somebody who is at least comfortable writing some programs in C programming. But this is by no means going to take you to an expert level in C programming. For that reason, I have an entire C programming playlist on this channel which you can check out that goes in depth into more of these concepts which we are going to be seeing in this video, and even other things which this video won't cover. But as I said, this video is a perfect introduction for you to at least know a bunch of things while starting out, which can at least take you to a level where you are comfortable writing programs in C up to a certain extent. Now let's get started with the video. In this video, I'm using the Dev C++ IDE, and assuming some people may be watching this who don't know what this is all about, we are going to see how to download and install Dev C++ IDE in order to write C programs. Okay guys, before we continue with the video, there is a type of software we are supposed to have in order to write our C programs, which is called an IDE. Basically, an integrated development environment, or IDE in short form, is a software application that we use to write, compile, and run our code. Popular IDEs for writing programs in C and C++ are CodeBlocks, VS Code, or Dev C++, which is my personal favorite for writing C and C++ in particular. Also, even if you don't have a computer, you can use your smartphone, whether Android or iOS, to write C programs through mobile compilers and IDEs, which can be found on the Play and App stores. I will leave links to my personal favorite mobile C and C++ compilers in the description for anyone interested in trying them out. For this video, I am going to be working with DevC, but if you already have another C or C++ IDE installed in your computer, you can still use it. For those who do not have any IDE yet, you can download and install DevC following these simple steps. First, you can head to the official website for DevC++ by searching the URL which is displayed on the screen, which will take you directly to the download page. Then click on the download buttons to download it. It automatically detects the operating system you are using and proposes the appropriate download setup. Once you click download, the download automatically begins, which you can check on your download section in your browser. When the download is complete, click on the downloaded file and it will run the downloaded setup ready for installation. The first preference asked is your preferred language, which I will set as English for mine. After that, simply agree to the terms and policies. Then on this page, click on Next to continue. You will then be asked to choose your destination folder where you want this application to be installed. Most of the times, you can just go with the one already proposed, which is what I will do, and just click on Install. However, you can choose the browse option if you want to install in another directory. Now I will click on Finish to complete the installation. Now the installation is done and DevC IDE is open. I am asked to choose language again, which I will set as English, and click Next. On this page, I can choose some customizations on how my IDE will look when coding. You can try out different options to see what you love best, but me, I like the Consulas font and the GSS Hacker color theme. Finally, just click on OK to finish everything, and now you are ready to start writing programs in Dev C++ IDE. Now, after you have completed your download and install of Dev C++, you can open the application by double-clicking on it, which is going to open the application as I have opened right now, and I'm going to create a file in which I will be writing my programs for this video. So I will come to the file option, which is at the top left, click on it and I will choose new to create a new file. I will choose new source file, and this opens a new file where I can write programs. Now, in order to write any program in C, there is a structure which I like to call the backbone of C programs, which is simply a format that you have to start by writing in order to run and compile any program in C. And this structure begins by writing an hashtag include stdio, which means standard input output.h. I will first write down all of this and then I will later explain what each of these things mean. Okay, so this is the backbone of our C program, and the first line which we have here, hashtag include stdio.h, it simply imports this library called standard input output.h, and this is simply something that enables us to be able to print and display things in our program, which we are going to see in some few minutes from now. After that, we have the int main function. So this is called a function, and it is simply where we are going to be writing our code or our lines of code in the program, which are going to be executed by our IDE. And finally, inside our main function, we have this line that says return 0, and return 0 simply means or indicates the end of our program, and anything we write after return 0 is no longer going to be considered as part of this main function again, which means it is not going to be executed as part of the program. So the first thing we are going to see is how to write and print a simple message that somebody who runs our program can be able to see as the result of this our program. So in order to do that, or to print something in C, we make use of something known as the printf function, which is used by simply writing printf followed by a set of parentheses, and then within these parentheses I can then print whatever thing I want to be displayed by the person who is viewing our program, and this message is going to be written within a set of double quotes inside our parentheses. So I will write my double quotes, and then I can simply print a message that is going to display the name and the age of somebody, for example. So I will write name equals Erling. That's just the name I like, and then I will say and age equals 20. Now I will go at the end of this line and add a semicolon. Every or almost every line in C programming usually ends with a semicolon, and this semicolon simply marks the end of this line. Most of the times when you write a line in C programming without a semicolon, it is going to generate an error when you run the program. Like you see with the return 0 line, we have a semicolon at the end, and even with the printf line, we have a semicolon. But on some things, like when we are writing things like functions or we are closing a function, the semicolon is not obligatory there. But just know that most of the times within your function or within the body of this program like this, and even out of the body, you will need to write a semicolon at the end of the lines. Now remember when I said this line imports the standard input output library that enables us to print and display things in our program in C. This is what I meant by that. Like we have this our line which we have written printf. What this does is that when we run this program, we are going to see this message that we have written inside here displayed to us as the result of our program, and this is enabled by the printf function. This function is a function that is defined in the C programming language, enables us to display results from our program to viewers, and this function is provided by this library I made mention of, which is the standard input output library. So in our program, if you know that you are going to print anything in your program, which is usually the case in almost every program I can think of that you will be writing, you will need this particular library, and you import it by writing this include at the beginning. In order to run this program, we can go to our taskbar up here in Dev C++, and the first thing we will need to do is first to save the program. I will click on this save icon here, or if you are using Windows like I am, you can simply use the keyboard shortcut Ctrl+S, and if you are using Mac, it is going to be Command S instead. So I will save this, and I am asked to give a name for the file. I'm going to call this C-tutorial, and then you can see this second option which says C source files. This indicates or marks the extension of this file as a C programming file, which is going to have the .c extension, because with Dev C++ you can write programs not only in C but also in C++, which has another file extension to use. And now I will choose where I want to save this file, which is going to be saved in my desktop, and I will click on save. And now the program is already saved. I can now run it by clicking on this other icon, which is the icon for running the program, and it says compile and run, so I will click on this. And now we see that we are displayed the message name equals Erling and age equals 20. This is what we got inside our printf message. You can see that printf itself is not displayed, but only everything that is within the double quotes is displayed. Now I'm going to copy this same line and print it a second time. When you just click on this one icon, it is going to save automatically. Now we see the same line is printed 2 times, name equals Erling and age equals 20, and it is repeating again because we have printed it 2 times. But we see that the 2 times that it is printed are printed on the same line and joined together. In order to make this to be separated on 2 different lines when printing or when viewing the result, we can add something to this function, which is the \n, backslash and then n. So this is going to enable us to give some spacing between our messages that we print. By default, the messages are printed joined together everything, but when we write \n at the end of our message, it means that when we print this particular line, our cursor is going to go to the next line before we print the second message, and so on. So I will run this again to see the difference this time around. Now we see the 2 lines are displayed separately. Now let's also talk about comments. Comments are simply things that you write inside your program in order to explain what is going on at a particular instance or moment in the program, so that when somebody else or yourself comes to look at the program after some time, they are going to know what you were trying to write or what you were trying to do in this particular phase of your program. So with comments, as I said, they are simply usually used to explain parts or to explain your code, but they are not going to be considered as part of the program itself when being executed. And in order to specify that something is a comment, you indicate it by writing 2 forward slashes before the comments, and you can see this becomes green already because Dev C++ changes comments to a different color. And now I can write anything that I want. I'm going to write. So my comment says, here I am printing details. Let me spell here very well. This explains what I am doing in this particular moment in my program. And if I run the program, we see that what we got as comment is not displayed, even though it is inside our IDE or inside our program. But if I remove these 2 forward slashes, this is no longer indicated as a comment because the forward slashes are what indicate that something is a comment. And let me run this again. We see that now we are given an error in our program because this right here is not any valid C syntax or code that we have written. So if something does not follow the rules and regulations of C programming, but we want it to be inside our program, it must either be a comment that is explaining something or give an error. Now, apart from the 2 forward slashes, we can also define comments by writing a forward slash and an asterisk, and everything after this is considered a comment. Now, in order to end these comments, we see that it has simply commented everything that we have in the program. Now, when we want to mark or indicate where this comment should end, we write another asterisk followed by another forward slash. So this is another way of writing a comment. And with this type of comment, it is known as a multi-line comment, meaning that it can be written across more than one line so long as it is between the forward slash and asterisk and the ending forward slash and asterisk. If I run this again, we see that we still get the same output. Now I am going to cancel this second line that we wrote here, and let's go to the next concept in C that we are going to see, which is variables. A variable is simply a memory location that stores a given value. You can simply think of a variable as somewhere that we go to store a particular value that we are going to access in our program anytime we want. Like here we are printing the name and the age of somebody in our printf message. We have the name Erling, which is the name of our person here. If you want to access this name again somewhere else in our program, like let me print back the second printf message that we have. We see that the next time that we are printing the message again, we have to say give the name Erling again, whereas we could simply store this name and the age inside variables, so that anytime that we want to access the name and the age, we don't have to explicitly rewrite the name and the age values again. We can simply access the variable in which they are stored and the values are going to be given to us. Now let's see how to create variables in this our program to better understand what they are and why exactly they are important or necessary. The first thing in order to create variables is to know about data types. A data type is simply a word that indicates the kind of value that a particular variable is allowed to contain or store. Now I have a small summary of the different important variables that we have in C. These are not all the variables that exist, but they are the ones that are important, especially for beginners. Here we have a table that represents or shows the different C data types. We have the name, the representation, main characteristic, and format specifier. So the first is the integer data type, which is represented by writing int, which is int, and its main characteristic is that it stores integer values. Integer values, in other words, are whole numbers like 1, 2, 3, or basically numbers which do not have any decimal points. And the format specifier for an integer is %z. We are going to understand more about what format specifiers are when we will actually create variables in our program. After integer, we have the float, and it is represented by writing float, but this time with a small f. And note that all the different representations that I have given, they are supposed to be in lowercase characters. Now, the main characteristic for the float data type is that it stores decimal numbers with up to 7 decimal places, and its format specifier is %f, as you can see. As I said, we will better understand the use of format specifiers when we actually create the variables in some few moments. And then we also have double, represented by writing double again, which stores decimal numbers also as the float, but this particular type stores decimal numbers of up to 15 decimal places, contrary to just 7 decimal places as the float could do, and its format specifier is %lf. Next we have the character data type, which is represented by char, and this is a data type that stores single characters. A single character can be anything like a single letter, digit, or special symbol or character. We can see the examples I have. We have A is a single character or a number like 3, or even special symbols like the asterisk or the ampersand symbol. When we say single characters, it means we cannot have something like 2 different characters like 9A, for example. This is already more than a single character, so it must only be something that is single, as we say. Also, take note that they are always written within a set of single quotes, as you can see. All the examples I have given here are written within single quotes, and its format specifier is %c. The next data type is the string data type, and this is represented using the char representation also for characters, but this time around it is a bit different. For the strings, we write char also, followed by the variable name. So this var name means variable name, which is simply the name of the variable that you are using in your program at that moment. And after the variable name, you will write a set of square brackets, and inside the square brackets you will write a number which represents the size of this variable. The size of the variable here means the maximum number of characters in total that you are going to be using, or that you are going to be storing inside this particular variable. And as we see, the main characteristic, as I said, is that it stores sets of characters rather than just a single character. For example, we have a set of characters that form the word Miami, which is the name of a popular city, and this means it is a string. And for strings, instead of single quotes, we write them within double quotes, and the format specifier for strings is %s. And finally, the last important data type we are going to see is the Boolean data type, represented by bool, and this is a variable which stores values that can either be true or false, and its format specifier is %z. I have a full video on my channel which goes in depth about these different C data types, and we even see examples of using each of them. So if you're interested in that or in knowing more, you can go and watch that video, which is going to be linked in the description, as well as the entire C programming playlist, which contains in-depth videos about various C concepts for those who want to know a lot more. But we are going to end here with this summary, and we are going to continue with our video or with our program. Now here we have two things that we want to store inside variables, which are the name and the age of this person. For the name, we are going to use the string data type, because we see what we said about the string data type is that it stores a sequence or set of characters, and names are usually written as set of characters exactly. We see the example, e.g. Miami, which is the name of a city, but now we are going to be storing the name of a person instead. We said string data types are represented by writing the char keyword followed by the variable name. I'm going to give it the name of name, and followed by my square brackets, and inside the square brackets I said you write a number that represents the maximum number of characters that can be stored inside this name variable. So I will write 10 for this example, which means that I want this variable to store a maximum of 10 characters, or in other words, the person's name should not be more than 10 characters. And I will set this equal to the name of the person that I want, which is going to be Erling. We are going to continue with the same name, and I will remember my semicolon at the end, and I will declare another variable for the age. The age is going to be an integer because ages are usually whole numbers. So I write int. We say that integers are represented by writing int, and I will give the variable name age and set it to a value of 20, because in our message we had the age as 20. Now, since the age is not a string, it is not written with any double quotes, we write it just like that since it is a number. And then now inside my printf message that I have, I am printing the name and the age. Now, instead of explicitly writing this name Erling again, since we already stored Erling inside this variable called name, we are going to simply reference the name here. So I will cancel this name Erling, and then I will simply tell my program that in the place of this name, I want whatever is stored inside the name variable that I created above here to be displayed. And in order to do that, we will now make use of the format specifiers. So since name was a string, remember that we said the format specifier for strings was %s. So here, instead of writing Erling, I will write a percentage and then an s. And for the age, it was an integer, and the format specifier for integers is %d, so I will write %d. So here I'm saying name equals %s while age equals %z. We have already created these variables above, so this %s is going to tell our program that in the place of this name, we should look for a string variable in our program and display the value contained by that string here, while %z means that we should look for an integer variable in our program and display its value that it contains here. Now let's assume that in our program we may have multiple variables, like more than 2 string variables, for example. Like, let me just declare another string variable here. Instead of name, I will say a country, and then I will change the value to Ghana. Now this makes 2 string variables that we have inside our program. So for this printf message to know which of these 2 strings it is going to take the value to put in the place of this %s, we need to indicate or specify the particular string variable which we want to put in that place. So to do that, I will write a comma after my ending or closing double quote in my printf message, I am going to now write the name of the variable that I want to be replaced by the %s. So I will say name. So when I write name here, it means it tells our program that in the place of this %s, we should look for a string variable inside our program and take the value of that string variable and put to be displayed here. Now, that particular variable we are talking about is the name variable, because if we don't precise that we want the name variable, the program is not going to know which of these two string variables we want to use. And so for the h, I have to also precise the variable that I want to replace this %g, which is supposed to be an integer. So I write comma h. Now let's run the program and we are going to see these values displayed. Now we see name Erling and h equals 20, which are still displayed as expected. I can now cancel this, my second string variable, because we don't need it anymore. Now with variables in C, the good thing about them is that once we have declared a variable and given it a value like we have here, we can later on access it in our program and give it another value. Like I can access this my h variable and give it a different value of 21, for example. Now once we have already created this variable, in order to access it another time in our program, we must not write its data type again. The data type is necessary to specify only at the moment when we are still creating the variable for the first time. But when it is already existing in a program, we can access it without indicating the data type again. In fact, if you even write the data type in front of it again, it is going to cause an error because the program will think that we are trying to create a variable that already exists. So I have accessed this variable h and given it a different value of 21. Let's run the program and we see that instead of 20, the h21 is going to be displayed now, which is what is done. This is because it was first of all 20, but we later on changed it and gave it the value of 21, and the printf message is going to take the most recent update that we have made on this variable. Now, what if in our program we have a variable whose value we don't want to ever change along the way in the program? Like we see, we first had our h, it was 20, now we changed it and gave it the value of 21. If we want to have a variable that does not allow its value to be changed or modified anywhere in the program, we can make that variable to be what we know as a constant variable. A constant variable is simply a variable, as I said, whose value can never be changed or modified. In order to make a variable constant, we simply go before the variable's data type at the time of its declaration or at the time of its creation, and we write the keyword const in front of it, which is const, and this makes this variable a constant variable now. And let's try to run the program again. We see that this gives an error this time around, whereas the first time we changed the value of h very easily, but this time it gives an error which says assignment of read-only variable h. This is because h is now a constant variable and we are trying to change its value on line 6, which is against the rules of constant variables because they are intended to never be modified, but here we are trying to modify it. That is why it has given an error. But if I remove this keyword back and make this variable no more a constant, we can see that we can run the program with no error again. So that is the use of constants in C programming. Now guys, we can see that so far we have written a pretty simple and cool program in C. But what if I told you that we could make this program more interesting by doing something else? So we see here we have our name and our h variables, which are assigned values directly, as name is given the value of Erling, while h is 20, which we later modified to 21. But we can also make this in a way that when we run this program, instead of just displaying the name and h the way they are given, we can actually tell the person running the program to insert values for the name and the h themselves, so that whatever name and h they provide are what are going to be displayed or given back as output. So let's make that modification here. I will first cancel this line 6, and then for my name and h variables, I will not give them any values. So I will cancel the equal to and the value for both variables. So here I just have name and age, which are just declared or just created, but they don't have any values yet. In order to then take these variable values as user input, as I said, we are going to make use of another function provided by the standard input output library, which is the opposite of the printf function and is called scanf function. So printf is a function that we use to display or to send things that the user can see, but scanf on the other hand is a function that takes values from the users instead to use inside the program. So let's complete this program in order to work the way I'm talking about. I will first write a message to the user, which is going to tell the user to enter his or her name and age. So I will use the printf function to do that. The programs are executed sequentially from top to bottom. So whatever is at the top is going to be executed first before we go to what is down. So what is going to be printed first is only going to be the first print. And within this printf function, I will write the message, enter your name. And I don't want my cursor to go to the next line after writing this message, so that the user can write his or her name on the same line. So I will not add any \n here. Now, in order to actually enable the person running the program to write something that is going to be taken as a value and put inside a variable in our program, we make use of the scanf function, as I said already. So this function is written as scanf followed by a set of parentheses also, just like the printf, and inside it we also write a set of double quotes. Now inside this function, I will go after my closing double quote first of all, and I will write a comma. Then after this comma, I will write name followed by a semicolon at the end of the line. So this name I have written here, it represents the variable called name, which we already have in our program. And this simply means that I want that the value inserted inside the program through this particular scanf function, this value should be taken and stored inside a variable called name. That is what this means. And inside my double quotes now, I am simply going to write the format specifier for this my variable called name. We know that name is a string variable, so its format specifier is %s. So I'll write that here, %s. So that is all what we have to do there. And I will do the same thing for my age variable. So let me copy these two lines and I will do the same thing for the age variable, because this right here, it's taking just the value for the name. Programs in C are executed sequentially, meaning that we will first of all start by what is on the top and start executing line by line till we reach the point of printing. We will first print the first printf message only, and only when the user reads this message and gives his value are we going to proceed to the next printf message that takes the age. So this time around, instead of name, I will ask for age, and I want the value that the user will give to be stored in the variable called age. So I will also change the format specifier to the format specifier of age variable, which is %z, because age is an integer. Now for this one, we will add one last thing, which is going to be a special character in front of the variable name age within the scanf function, and this special character is going to be an ampersand symbol. So the ampersand symbol means we are going to take the value that the user gives and store it within the variable called age. Usually we have to always include this ampersand symbol when specifying the variable name that we want the value to be stored in. But the only exception is when we are dealing with string data type. For string data type, the ampersand symbol is not supposed to be there, because that is how C functions. You will better understand the reason when we start working with things like pointers in C, but for beginners level, that is not something you should bother about. Just know that, or just memorize it in a way that when using the scanf function, at the level of specifying the variable name which you want the user's value to be stored in, you include an ampersand symbol before the variable name. And the only exception is when the variable name is a string. In that case, you don't need to include any ampersand before the variable name, otherwise it is going to cause confusion. So for strings there is no ampersand, while for other data types there is an ampersand included. Now we already have everything working as expected. For the third printf message, we will leave it exactly as it is, because when the values are going to be given by the user, they are going to be stored in the name and age variables, and they will still be printed as we had normally. Now I will run the program, and this time around I'm going to give different values for the name and the age. So for the name, I'm going to give the value Wilson, and after writing the value I will press enter on my keyboard to go to the next line. So the value for the name has been taken successfully already. And for the age now, I will also give a value which is 30. So the age of this person is going to be 30. The name is Wilson and the age is 30. And I will click on enter to go below again. And now we see that the name and the age are displayed. Name equals Wilson and age equals 30. Just as we expected to see. Now, as I said, you can always visit my C programming playlist on this channel in order to see more of what you can do with these various things I'm showing, like the scanf function for example. I have a full video on that which shows more things you can do with scanf rather than just taking user input this way. There are other things you can also do with it, but for the level of this crash course video, assuming you are complete beginners, I think this is already going to take you a long way. Now let us talk about another very interesting concept in programming and in C programming, which is loops. A loop is simply a way of doing or executing a specific instruction in your program multiple times. For example, this is a good example that we can use for the loop. This line where we are printing the name and the age obtained from the user input. Now I am going to use a loop to execute this particular instruction or this particular line multiple times, so that if you want to display this result, let's say if you want to display this particular name and the age 5 different times, you can simply copy this line as such and then you paste it 1, 2, 3 and 4 times. Now we have the line a total of 5 times, but this makes the program look more cumbersome. Let's imagine you wanted to display this 20 times. It means you have to copy this same thing and paste it 20 times. But with a loop, you can execute particular instructions. It can be more than one instruction even, but you can execute instructions multiple times, as I said, without having to copy and repaste the same lines of code. So let's use a loop to display this message 10 times. So in C programming, there are different types of loops. The first one is going to be the for loop, which we are going to see. So to write a for loop, you write the keyword for, followed by a set of parentheses. And then here I'm going to say int I. I will just write the entire loop, and then after that I will explain what each part of the loop means. So here we have my loop that I have written, which is for loop. That is where I've written the keyword for before it, followed by this set of parentheses. Inside the parentheses we have int I equals 0. So I is what I'm going to call an iterator, which is simply a variable that counts the number of times our loop has been executed or has been run. So initially I am setting I to 0, and then the second part of this loop is I less than 10. So this first part, I equals 0, means I am starting to count as from 0, while the second part of this loop where I've written I less than 10 is what we know or we call as the exit condition. The exit condition is a condition that we are going to verify with relation to this I variable that is determine how many times the loop should be executed or should run. We see that we are starting our counting at I equals 0 when I is equal to 0, and then now in this condition we are saying I less than 10. So where we are saying that we are counting the values as we are counting the number of times that this loop is running with the I variable. The condition for us to keep on executing or running this particular loop is that I should always be less than 10. So I'm repeating again for the last time, I is starting at 0, and then so long as I is less than 10, we are going to continue running the instructions inside of this loop. And the third part is what is known as the increment condition, which is I++. The increment condition is simply what is going to make sure that the value of I keeps changing with every iteration of the loop. So an iteration, I keep saying the word iteration, and an iteration is simply a particular time that the loop is executed. For example, if you want the loop to be executed 3 different times, it means we have 3 iterations in that loop. Each time the loop runs is an iteration of the loop. So in our exit condition, we have I less than 10. It means we are going to be executing this loop so long as the value of I is less than 10. And since I begins at 0, this increment operation makes sure that after each iteration, the value of I is increased by 1. So when we say I++, it simply means we are increasing the value of I by 1. That is what this plus means. It means take the current value of I and you add 1 to it. Now after this, we have our brackets, and within the brackets we can write the different instructions we want to be executed inside this loop. So I'm going to copy this, my printf line here. I'm going to cut it from here, and then I will paste it inside the loop. So this is the instruction that we want to execute multiple times in this loop. Inside the loop, we can have more than one instruction. We can have as many instructions as we want, but just because our program is a simple program, I'm going to have just one instruction inside this loop. So what this does, it is going to run this instruction inside the loop 10 times. Now I'm going to run the program for us to see the output, and we see that this gives an error. It says for loop initial declarations are only allowed in C99 or C11 mode. So basically what the error is telling us is that we are not allowed to declare the variable I within our for loop. This normally is supposed to work in most compilers or in most IDEs, but apparently the one I am using does not allow this feature. But an easy alternative way of doing this is I can simply cancel this data type we have here, which indicates that we are not initializing or we are not creating this variable I for the first time, and I will write it rather above the for loop. So I'll write int I, which creates the variable I already in our program, which we are going to just access and use in our for loop now. And now we see the program has run successfully. We are asked to enter the name. I'm going to give the name of Wilson. I will maintain the same name. Age, I'm going to give 30. And now we see name equals Wilson and age equals 30 is displayed a total of 10 different times, because our for loop says we should display this message 10 times. Now another loop we are going to see instead of the for loop is the while loop. So its function is same as the for loop's function, which is to execute a given instruction multiple times, but they have some few differences in the way of using them. So for the while loop, instead of for, I will write the keyword while, and then the while loop, it does not take all of these different parameters like the for loop does. So the while loop, the only thing we are trying to check in the while loop is the condition for which we want to keep running the loop. The condition is going to be as long as I is less than 10. So I will still write I less than 10. I will maintain the same condition, and for that reason I will have to give I the value or a given value here, which is going to be 0. If I want to run the loop 10 times, I need to start at I equals 0, so that it is going to execute so long as I is less than 10, and this is going to cause us to execute the loop 10 times in total. But we see that here we don't have any increment operation like we had in the for loop, which automatically increases the value of I by 1 after each iteration of the loop. So for that reason, with the while loop, we need to explicitly write the incrementation ourselves. So I will go on the last line of the loop, I will write I++. I'm going to write it as an instruction that is part of the instructions of the loop, I++. So it is also going to increment the value of I after each iteration of this loop. And if I run the program, we see that everything is going to work just the same as with the for loop. So enter your name, I will give the name, age, I will give the age also, and we see the name and age printed 10 times as was done with the for loop too. Let's now continue this video by talking about something different. We are going to now talk about conditional statements in C programming. Conditional statements are simply a way of performing given set of instructions based on given conditions, whether they are true or false. Now there are different types of conditional statements that we have in programming or in C programming, but we are going to start with the most common one, which is the if statement. So the if statement is a type of conditional statement in which we check a condition, and if this condition is true, we perform a given set of instructions, and if it is not true, we may have another set of instructions to perform in the case where the condition is not true. Now let's see with an example in this our sim program. We are going to make of the if statement to say if the age of this person given makes the person a child, an adult, or an old person using the if statement. So we are going to function on the principle that anybody less than 18 years old is a child, while between 18 to 55 is an adult, and above 55 years old is an old person. So let's continue from there. We are assuming that the age is already given since we have already asked the user or the person running the program for his or her age. Now we are going to continue with the if statement. I will write if followed by a set of parentheses, and then inside here I will specify my condition that I want to check. So the condition is going to be to check if the age is less than 18. So I will write age less than 18 like that, and I will follow this with a set of braces, and inside these braces I'm going to now write the instructions that I want to be executed if this condition age less than 18 is true. So if the age is less than 18, I want to print a simple message that says you are a child. We don't make use of any variables here, so we are not going to use any format specifiers inside our message. And so that is how we make use of the if statement. Now we can leave this just like this, and we try to check the result of the program. I'm asked to enter name. Then for the age I will give 10. Now they tell us you are a child because our age is 10, which is less than 18. But if I try this again, now I'll give an age of 20, and it doesn't display anything because this time around the condition was checked and it wasn't met, or it wasn't true because the age was not less than 18, so nothing was printed. Now if you want to have a situation where even if the condition is not met, we will still have something else or another set of instructions executed, we can also make use of the else statement, which is accompanied with the if statement. So we will write else, and we will specify another set of instructions to be executed here. And in the case where the condition age less than 18 is not true, whatever is inside the else block is going to be executed. I'm going to say here you are not a child, and we will run this again. Now I'm giving the age of 20, and if I press enter, we say we get you are not a child because the age is not less than 18. Now instead of checking just one condition like we check here to see if the age is less than 18, we can also check or add other conditions to check to this. As I said, we want to also check if the age is between 18 to 55 to say that the person is an adult, and greater than 55 to say the person is old. So to add more conditions, we make use of else if statements. So I can simply write else and then space, after else space, and then if, and then I will write another set of parentheses. Within this I will write a second condition now. So the second condition will be to check if the age is less than 55. So our conditions first start checking from the first one. We first check if the age is less than 18. If this isn't true, we will check if the age is less than 55. Now we simply have to write age less than 55 because we are already assuming it was not less than 18 before reaching this point. So by the time we reach this point, it means we are checking actually if the age is between 18 to 55. So I will also write a set of brackets and write another set of instructions to be executed if it is the second condition that is true. And here I'm going to print you are an adult. So as I said, we start by checking from the start or from the first condition, and we check this condition if and only if the first condition age is less than 18 isn't true before we move to the second condition. And by the time we move to the second condition, it means we have already determined the person is above 18. So when we are checking age greater than 55, it means if this is true, the person is surely going to be above 18 but less than 55. And in that case, we say the person is an adult. And finally, else if the person is greater than 18 and also greater than 55, we are going to say the person is old. It's just for the example. So instead of printing you are not a child, I will actually print you are old. And now let's go on to see the results. I will enter the age 30 and it says you are an adult. Now let me enter an age which is greater than 55 also. I will enter the age 60 and it says you are old. So that is how to use if statements in C to check conditions and perform instructions based on whether the conditions are true or false. Now similar to the if statements, there is another type of conditional statements which we have in C, which are known as the switch statements. So with the if statements, it enables us to check conditions with ranges, like we say here for example age less than 18, and then we perform or we print something based on that condition that we have checked. Of course, we can also check exact values, like we can check if the age is equal to 18 like this, and then if the age is equal to 18 we print a message. Now take note that when you're comparing values in C, instead of using a single equal to symbol to check if the age is less than 18, we will actually need to use a double equal to. So this checks if the age is equal to 18, and if this is true we will need to print a message like you are 18 years old. Let's actually do that. I will just say you are 18. Okay, the message says you are 18. So that is something we can also do with the if statements. But when we want to compare exact values like we have here, what we can easily use apart from the if statement is known as the switch statement. So it makes it a bit easier when you are trying to compare exact values rather than ranges. Like age less than 55 is a range because when we say age less than 55, it covers a whole lot of numbers like 54, 53 downwards. But we are trying to talk about a situation where we are checking exact values like 18, 20 and so on. So we can use a switch statement for that. In order to do that, we write the keyword switch followed by a set of parentheses seal, and then within our parentheses we are going to write the name of the variable age or whatever value you are trying to compare here. So here we are going to be comparing the age with different other values. So that is why we write the variable name age here, because that is the value we are going to be comparing, and we follow this with a set of brackets. Now inside the switch we are going to have different values that we are comparing the age to see if the age is equal to those values, and those values are going to be defined inside some little blocks of code known as case blocks. So I will write case, and I can write case followed by a value, like for example case 10 and with a colon after it. So when I write case 10 with a colon, it means I am trying to compare the age to see if it is equal to this value 10, and if that is true, I will perform an instruction or a set of instructions below here. So if the age is equal to 10, I want to tell the user you are 10 years old simply. It's a pointless message, but let's just do it for the sake of this example. And after this, I can also add another case to compare age to another value that I want. So I'm going to say case again, and this time I'll say 20. And if this is true, take note that this works just as the if statements also. We start by checking the very first condition before we move down to the other conditions, and we only move to the following conditions below if the first condition above is not true already. But if this is true already, we will not need to move to the next conditions to continue checking anything. So in that case, once we complete the first case, we add a keyword which is the break keyword. Break simply means, or it enables our switch statement to make sure that if a given condition is already true, we don't need to continue checking the other ones below it again. So break makes us to exit the switch statement at once. So for the case 20, I will copy these two lines and paste also below it, and I will simply change the message to you are 20 years old. And I can add a third one just for the sake of practice. I will say case 3 or case 30 to check if the age is 30. Remember I said with the switch statement we are checking exact values, not ranges. So when I say case 10 for example, it means if the age is exactly 10, not in between 10 and less than 20 like we would have done with the if statement. Now here I will also print the same thing, but I will change 10 years old to 30 years old. And finally, when we have checked all the amount of cases we want to check, you can put as many of them as we want. But at the end, we should add another block within the switch statement, which is the default block. It is written as default followed by a column. And what this default does is that after checking all the cases above, if none of the cases match our value, which is the value of the age that we have checking or that we have specified to check here, if none of these cases match the age, we are going to execute another set of instructions in which in this case we will simply be telling or displaying another message to the user, which may be to tell the user that we have not found their particular age or something else. So I will change your 10 years old message to say I don't know your age. Now let's run our program again to test. I will enter a simple name just to save time, and then for the age I will say 10, and it says you are 10 years old. If I give 20 or 30, it will also print the corresponding message. And let's run it another time to give a value which is not 10, 20 or 30. I will give an age of, let's say, 50, and it says I don't know your age because we did not specify any case for the age being equal to 50. Now, as I said, with the switch statement we check exact values, but we can also make our switch statement to be in a way that we use the same result or the same output for different cases. Like here we have age, we are checking, or we are comparing age to see if it is 10, and we are printing you are 10 years old. And for 20 we also have you are 20 years old. But what if you had a message that we want to print to be the same message printed if the age is equal to 10 or 20? In that case, we can either come below, let's say the message can be to say you are 10 or 20 years old. Let me actually write that. Now I could simply copy this same thing and then come and paste it within the message of case 20. But what we notice here is that this doesn't really help us in any great way, because at the end of the day we are still doing almost the same amount of work, because it has not saved us any lines of code. But a better way of doing this is that we could combine multiple cases for a given output. So here I could simply say case 10, and then I go below and say case 20, and I will cancel case 20 from here. So now in this case we are checking the case 10 and case 20, and if any of them matches the value of the age, we will print the message you are 10 or 20 years old. So here we have combined two different cases for the same output, and we could also combine more than just so. We could add as many of them as we want. We can even say case 15 here. So the point is that you can add as many of them as you want. I will say you are 10, 15 or 20 years old. And after this, we can still keep the other individual cases as they were, or we can even decide to also make this case 30 to be joined to another case like case 25, but I will not do that just to save time. And the point is that you can add as many of them as you want, and you can also decide to leave them individual as you want also. And I will still keep my default block also, just in case none of the values actually match the age value. Now let's try this again. Name age, I'm going to enter the age 15, and it says you are 10, 15 or 20 years old. So guys, that is how to use the switch statements in C programming. Now the next programming concept that we are going to talk about in this video is functions. A function is a block of code or a sequence of lines of code that you group together in a particular package such that you can use multiple times in your program simply by calling the function without having to rewrite all the lines of code that are within that function. Now we are going to better understand this with the help of an example, of course. So remember when we were talking about if statements, let's write an if statement that checks if our given person is a minor or an adult based on the person's age. So we are going to assume that any age less than 18 is a minor while above 18 is an adult. So I have a simple if else statement here which checks if the age is less than 18 and says you are a minor, and if the condition is not true, meaning that the age is surely greater than 18, it's going to say you are an adult. So let's say if you have two different ages, and for the sake of this I'm going to cancel this user input here so that we should no longer be taking the name and age as user inputs, since it takes us some time just to input the values when we run the program. So I'm going to set values for name and age myself already. I will set the age to 10 to start, and the name will be Nelson. Now let's just say we had another person's age which we wanted to check also. I'm going to create a second variable called age2. Let's assume that this age2 is the age of another person, and I'm going to give it the value of 23. Now we have two ages here. If you wanted to also check if the person with age2 is a minor or an adult, we could still copy this if statement here and paste it below, and we are going to change age from age to age2. So we have one if statement that checks for age and the other if statement checks for age2. But let's say if we had another third age again, age degree, which I will give the value 33. We see that if we want to continue using the same if statement to check all these ages, it is going to become very cumbersome because our program is going to go in so many lines, since only for one if statement it already takes about, let's see, it takes about 6 lines it alone. So we will have to multiply that 6 by the number of ages that we want to check, and we see that that is going to be very cumbersome even though it is going to work. Like, let's run this just to check. We see that the first one says you are a minor while the second one says you are an adult, because we use initial age and h2 to check. But with the use of functions, we can write all of this logic that checks the age, or that checks if the age is a minor or an adult. We can write all of the logic just once, and then we use it for as many different ages as we want. So let's see how to do that. I'm going to cancel this if statement for h2, and then I will create a function. A function is a block of code that contains different lines of code that we want to use multiple times without having to rewrite. So that's an easy way of thinking of a function. And in order to create a function to achieve what we are trying to achieve here, I will go at the top of my program after the include line, and then it should be in between the include line and also above the int main function. So this int main is a function that defines the body of our C program, but we can also have functions to do other specific things like what we are going to do now. I will write void, and after void I will give a name for this function. So I can say the name is check age, because that is what the function tries to do, followed by a set of parentheses and with a set of brackets at the end also. Now within this my parentheses, I'm going to add what is known as a function parameter. A parameter is a value, or it can be multiple values that we send to our function in order to perform something specific, in order to use them perform an operation or something specific. Now inside this my function, I will copy, or I will cut all of this if statement. I will cut it from the body of the program and paste it inside my check age function. Now I have a function which is called check age, and what it does is that it checks the given age of the person that we want. But we see here we are using the age inside our check age function, but there is no age in this check age function. This is because even though we have created or defined our age variable inside our main function, it is available and accessible only in the main function but not directly in the check age function. So in order to make it to be accessible or used in the check age function, we need to pass it as a parameter in this check age function. As I said, a parameter is something that we write within these parentheses of the function, and it is going to use this given value to do something with it inside the function. So I'm going to pass the age here as a parameter in this function, and before passing it as a parameter, I need to give the data type of this parameter. With the age is an integer, so I will write int age. And now we can use age inside the function, because when we write age here, it is going to know that we are making reference to this age that we have sent to it as a parameter. And then now, since we have already created and defined this function above our main function, inside the main function now we can simply access this check age function, and it is going to check the age or whatever age we want. Now to make use of the check age function, I simply have to write the name of the function in my main function, check age, followed by a set of parentheses and my semicolon at the end. So when I write check age, it is going to know that we are making reference, or we are trying to use the function which we define as check age above. And you notice that this check age function takes a parameter which is the age. So when I call the check age function, I need to also pass a value within it that is going to be used as value for the age as we have there. And I already have a variable called age inside this function, so I will just write age again. So this age is going to be passed as parameter in that function, and you can run the program to see what it is going to say. It says you are a minor. So you are a minor because we have passed the value age. We know that this age is a variable which contains the value 10. So when we write check age with age inside the parentheses, it is going to send the value of age here. So here we have int age. This is actually the value of the variable age 10. So here we are also going to check if 10 is less than 18 and so on. It is going to give the messages as specified. Now, as I said, we can create the function once and use it in multiple places in our program. So that is what we are going to see now. I will call check age again, and this time around I can pass any other value that I want. So I will simply say age2. because we already have age 2. Or I can also decide to cancel these two other ages 2 and 3, and instead of accessing a variable, I pass in any number that I want as age. I can give an age of 50, and I can also decide to cancel these two other ages 2 and 3, and instead of accessing a variable, I pass in any number that I want as age. I can give an age of 50, and I can even copy this again and call the same function as many times as I want. The next one, I will give an age of 23, and lastly I will give an age of 5. So we see that we simply have to call this check age function by writing the name, because we have already defined or written its instructions or its logic inside the function above here, and below we can simply call this same function and use it many times. Now let's run our program to see our different results. We get 4 different results because we called the function 4 different times. So guys, that is how to use functions in C programming, and there are a lot more that I think you should know about functions, so I will highly advise that you go and watch my full entire video on functions in this channel also. But as I said, this is aimed to be a crash course for complete beginners with not much time wasting. That is why here we are showing just the bare minimum, but you can still watch the other videos for more or deeper knowledge in order to learn more about these various concepts. Now the next thing we will talk about is an array. An array is a way of storing multiple values having the same data type. Now for example, we can have an array of numbers that stores different numbers of a given data type, like integer for example, which is going to be an array of integer numbers where we can have several numbers like 1, 2, 100 and so on, so long as all of them are of the same data type. So in that case, I will also create an array of ages. Instead of having just one age as we have in our program, we are going to have ages of many people at the same time. So to create an array, we start by giving the data type of the array, because as I said, every element in that array must have that same data type. So I want to create an array of ages, and ages are going to be integers, so I will say int, give the array name as ages, followed by a set of square brackets, and within the square brackets I will write the size of the array. The size of the array simply means the maximum number of elements that we can store inside this given array, and I will give the size as 5. It means that if we try to store more than 5 elements in the array, after 5 elements the other ones will no longer be considered. And I will set this equal to a set of curly brackets. In the curly brackets, I can simply write each of the elements, separating them with a comma. So the first age I'm going to write is 18, 12, 35, 40. So I said the maximum number of elements you can store is 5, but if you want, we can store less than 5 elements actually, and I will remember my semicolon at the end. So these are the various array elements, and these array elements can be accessed using what we call indexes. An index is simply the position in which a given element is found in an array. Like here we have this 18, this is the first position, but with arrays the positions are counted beginning from 0. So 18, which is the first element, is actually going to have the index of 0, while 12 is the second element, but it will have the index of 1. So the positions or indexes are counted starting from 0 in arrays, and I can access these given indexes to modify their values or do anything I want to do with the values. Like I can say ages. To access the array, I will simply write the array name ages followed by the set of square brackets, and inside the square brackets I will write the index of the array that I want to access. Like if I want to access the first element, as I said, it is going to have the index 0, so I will write ages 0 here, and I can give this a value of 13. So what I'm doing is I'm modifying, or I'm changing the value from 18 to 13, and now the value of ages at index 0 is going to be 13 instead of 18. And I can also access ages at index 4. Now 18 is index 0, 12 is index 1, 35 is index 2, and 40 is index 3. But these are only 4 elements. I can add a fifth element because our size says 5 and we only have 4 elements, so I am allowed to add another element, and I'm going to say index 4 because the fifth element is going to be at index 4, given that the indexes start at 0. So I will say index 4, and I will pass this my age variable at index 4, so I can say index 4 age. What this does is that it's simply taking this my age variable and adding it to this array. It is possible to do that because age is also an integer, as the array of ages is an integer. Now let's try to print the elements of this array. We can print the elements of an array using the printf function. So I can say if I want to print a given element at a given index, I will simply simply say %d. I'm writing %d because it is the format specifier for integers, and the array of ages is an integer array. Now to print an element, I can only print an element at a given index at a time. I cannot print the entire element of the array. So if I want to print the element at index 2, which is going to be 35, I will write the array name ages and specify the index that I want, which is index 2. So when we run the program, it is going to see this %d and know that %d needs to be replaced with an integer value, and we specify that value here, which is ages 2. It means we want to go to the array called ages and print the value at index 2 of that array. Now let's go on and see. As I said, it's supposed to print 35, which it does. It has printed 35. Now if you want to see how we can print all the elements of the array at once, we can do that using a for loop. We already talked about for loops earlier in the video, so we are going to make use of a for loop. Write for, and I will say I equals 0. We already talked about for loops and we saw what this variable I means, which I said is an iterator. So we are using it to count the number of times the loop is executed, and we are initializing I, or we are beginning I at 0, which is convenient in our example because the array indexes begin at 0 also, and we are going to continue running the loop so long as I is less than 5, and after each iteration we increment the value of I by 1. After this, I've got my curly braces and I can specify my set of instructions for this loop, which is going to simply be this printf message that I have here, where I was printing a value from the ages array. I will cut this from here and put it inside my for loop. So instead of printing just the value at index 2 of the ages array, I will print the value at index I, as we know that I is a value that changes from all values between 0 to less than 5. Less than 5 is going to be 4, which is the last index of this array. Now before I run this, let me remember to declare my variable I, so that it should be existing in the program, because if we try to use I like this without declaring it anywhere, it is not going to work. And we remember that initially I tried to declare it within the for loop. It is possible to do that, but for some reason some IDEs apparently don't accept that feature. So I will run the program like that, and we see all the elements of the array are displayed one after another. So that is how to use arrays with for loops in C programming. Okay, now guys, the next thing we are going to see in this video are structures. A structure, or a struct for short, is a way in C for creating your own custom data types which can store different related values under the same name. So we can see in our example here, we have the name and the age of a person, and we are given the name as Nelson while the age is 10. This name and age are related because we are considering that they belong to a unique person who has a name and an age value. So we can easily represent something like this with a structure, which is simply a type of data type that we will create ourselves, that enables us to create a single variable which stores the name and the age of a person in a way that enables us to reuse for different variables at a time. Now let's see an example of what I'm talking about to better understand. I will start by cancelling everything we have in our program so far, and I will also cancel this checkH function. Now in order to create a struct variable, we need to first create the struct data type, as I said, which is going to be defined in between the include statement and the main function initialization, which is going to be done between the main function and the include statement. So similar to where we created our checkH function, we are going to create a struct using the keyword struct, and then we will give this struct a name. By convention, struct names always begin with an uppercase character, and I'm going to call this struct person, because I want it to have a name and an age, which are going to be the name and the age of a person. And I will follow this with a set of brackets. Notice that the semicolon has been added at the end of the struct automatically for us. Now inside this struct, I can define various variables that I want to use for representing a unique person. I can give as many attributes as I want, and these attributes are simply variables that are going to be formed or stored inside this struct. So the first variable I'm going to give in the struct is going to be the name, which I will declare like a regular variable in our program. I will say char name, and the name of and I will give the size of the name as 20, and I will also create or declare a variable for the age. It's going to be an integer. Okay, now I have created my struct. As I said, you can think of this struct as a way of creating a custom data type, so so that when you create a variable with it, you can create a variable of type person instead of using a normal data type like char or int for storing single values like age or name. You can use a struct as data type. That means you're going to create a variable of type person using person as the data type, and inside this person you can have sub values then like name and age for this given person. So now I will go in my main function or in the body of my program, and I can then create a variable using our struct person as the data type. So in order to do that, I will write struct, which is a keyword, and followed by the name of my struct, which is person. Now after saying struct person, I will give a name for this struct variable. So the person we have here is simply the name of the struct which we are using as data type, and after this we have to now write the actual variable name we want to give. I'm going to call this person1 with a small p this time around. Now I am going to give values for person1's name and age within a set of braces, and I don't need this to be on different lines. You can maintain it on different lines if you want, but I'm going to make it to be actually on the same line. So now within my braces, I can give the value for persons1, I can give the value for the name, and we know that the name is a string and strings are always given within double quotes. So I will write a set of double quotes and I will give the name of person1. I can give any name that I want so long as it is less than 20 characters. So for the name, I'm going to give Pedri, and for the age, I will first write the comma after the closing double quote, and I will give the age for this person. Now I'm going to give the age of 19. So I'm saying person1. Automatically when we write it like this, it is going to take this name and set as value for the first struct attribute, which is the name. Remember that the variables we define inside the struct are called the struct attributes, and the second value is going to give it to the second attribute of the struct, which is the age, and they need to be in the same order. You cannot write 19 before Pedri because name was defined before age, and if you mix up the order, it is going to cause confusion, which will lead to errors also. Now that we have created our struct variable called person1, we can then access the struct variable with its values inside and do whatever we want with them. For example, we can access the person1 struct variable, and then in order to access any of its attributes, we simply use a dot symbol. So we say person1 dot. We see that here we are proposed the different attributes inside of this struct. We have the age and the name. So I can say person1 dot name, and then I can modify the name to give something else. I can give it anything, or I can also say person1 dot age and say equal to and give it another age. I will actually change this age and give it the age of 23. So here I'm saying person1 dot age instead of 19, it is now going to be 23. And then we can even decide to print this out. We are going to print the name and the age of person1 now. So let's say we are going to use a printf function, and I will say name is going to be equal to %s because that is the format specifier for a string, and the struct attribute name is a string. So we are still going to use the notion of format specifiers here, and I will say comma age is equal to %d, and I will put my \n so that I can print something after on the next line. And now for the values that are going to be printed in the place of the format specifiers, for the age, which is a string, I want person1 dot name to replace the %s format specifier. Remember I said we can access the struct attributes using the dot symbol, and I can also say person1 dot age for the age format specifier, which is a %g for integers, and I will remember my semicolon at the end of this line. Now let's run this program to see the result. So we see we have name equals Pedri and age equals 23 as expected. So that is how to use structs to create variables or more complex variables that enable us to store values of different data types which are related. Now since we have already created our person struct, and we have even created a struct variable already, we can create as many other struct variables as we want. Like for example, I can create a second struct variable here, which I'm going to call person2. I will change person1 to person2, and then person2 I'm going to give him the name of Rodrigo, while the age will be 21. And now I can also access and print person2 name and age, which I'm going to do. I will copy this my printf message and paste it below. Then I will simply modify or change person1 to person2 in both the name and the age. Then I will run this to see the results. Now we can see name equals Pedri, age equals 23, and below we also see name equals Rodrigo and age equals 21 for both persons 1 and 2. So guys, with this we come to the end of this C programming crash course, and make sure to check out my C programming playlist on this YouTube channel in order to have access to all my other C programming detailed videos. But as I said, this is a beginner friendly video for the main concept everybody should know in C, even if you don't intend to go deeper into any of them. So thanks for watching, and please subscribe to the channel for more videos. Thank you.